Concurrency bugs that involve a race condition to a shared resource can be solved by using a mutex, where mutex stands for mutual exclusion. The easy solution is you disable interrupts when touching a shared variable. It inhibits task switches, but you need to keep this very brief in order to avoid timing problems. If you need to hold a shared resource, such as a global variable, for more than a handful of clock cycles, you can use something heavier weight called a mutex, which is a mutual exclusion flag. It's a flag that when the flag is true, the resource is busy, and when it's false, the resource is available. So to use this means that each global variable or other shared resource, it might be an ADD converter, it could be a hardware resource too, has with it a flag. So that's right, you have to have the global and you have to have another variable that's a flag. And the flag tells you whether or not it's safe to access the global, depending on whether some other task is using it. So to solve the problem we saw on the previous slide, to access this shared resource in a safe way, you first get the mutex. So here, there's global variable 5, task 1 gets the mutex, and the mutex happens to be free, so it gets back an OK. In other words, the mutex is false. And by the way, when it does that, as part of it, it sets it to true, so everyone else knows that the mutex is true and the global variable is taken. It does the read, and it adds 1, so task 1 is at 6, same as before. But when a task switch occurs, task 2 goes out and says, hey, I want to access the variable, let me get the mutex. But because task 1 has set the mutex to busy, task 2 says busy and says, oh, okay, someone else has it. It relinquishes control, the task switches back to task 1. Task 1 completes the write, putting the correct value of 6. And later on, the next time task 2 tries to get a task slice, it'll say, get mutex, oh, the mutex is free, and it'll be okay. Of course, that only happens if task 1 releases the mutex, which sets it to false when it's done. Be sure to remember that mutexes themselves are also a special type of shared variable, so you have to use great care in making sure you build this system. Going back up to the top of the slide where I said you could disable interrupts, really the trade-off looks like this. If you have a shared variable and all you're going to do is add 1 and put it back, you might just as well disable interrupts, add the 1, write it back, re-enable interrupts. But if you're doing something complicated, like you have a large data structure and you don't want to hang the processor up with the interrupts disabled for too long, you instead use the disable interrupts to set the mutex, re-enable interrupts, and now that the mutex is set, you can do whatever you want because you have exclusive use of the resource. And then when you're done with the resource, you release it by releasing the mutex, just setting it back to false, and now some other task can use it.